Introduction. By comment to this section of the audiobook where we explore a comprehensive list of JavaScript functions, grouped by categories like strings, arrays, objects, and more. Each function will be described concisely to give you a quick understanding of its purpose and usage. String functions. Char at index returns the character at the specified index in a string. Concat string 2, string 3, combines two or more strings into one. Includes search string checks if a string contains the specified substring. Index of search value returns the index of the first occurrence of a specified value, or -1 if not found. Last index of search value returns the index of the last occurrence of a specified value, or -1 if not found. Slice start, end, extracts a part of a string from the start index to the end index. Split separator splits a string into an array of substrings based on a separator. To lowercase converts a string to lowercase. To uppercase converts a string to uppercase. Trim removes whitespace from both ends of a string. Replace search value, new value, replaces a specified value with another in a string. Substring start, end, extracts characters from a string between two specified indices. Repeat count returns a new string with a specified number of copies of the original string. Array functions. Push element adds one or more elements to the end of an array. Pop removes the last element from an array and returns it. Shift removes the first element from an array and returns it. Unshift element adds one or more elements to the beginning of an array. Concat array 2, array 3, merges two or more arrays into a new array. Join separator joins all elements of an array into a string, separated by a specified separator. Slice start, end, returns a shallow copy of a portion of an array. Splice start, delete count, item 1, item 2, changes the contents of an array by removing or replacing existing elements and adding new elements. For each callback executes a provided function once for each array element. Map callback creates a new array populated with the results of calling a provided function on every element. Filter callback creates a new array with all elements that pass the test implemented by the provided function. Reduce callback, initial value, applies a function against an accumulator and each element to reduce it to a single value. Reduce write callback, initial value, applies a function against an accumulator from the right side of the array. Sum callback checks if at least one element in the array passes the test implemented by the provided function. Every callback checks if all elements in the array pass the test implemented by the provided function. Find callback returns the first element in the array that satisfies the provided testing function. Find index callback returns the index of the first element that satisfies the provided testing function. Sort compare function sorts the elements of an array in place and returns the sorted array. Reverse reverses the order of elements in an array. Object functions. Object.keys obj returns an array of the object's own enumerable property names. Object.values obj returns an array of the object's own enumerable property values. Object.entries obj returns an array of the object's own enumerable string keyed property, key, value, pairs. Object.assign target, source, copies all enumerable properties from one or more source objects to a target object. Object.freeze object freezes an object, preventing new properties from being added and existing properties from being modified. Object.seal object seals an object, preventing new properties from being added, but allowing existing properties to be modified. Object.create proto creates a new object with the specified prototype object and properties. Number functions. To fixed digits formats a number to a specified number of decimal places. To precision formats a number to a specified precision. To string radix converts a number to a string in a specified base, for example, binary, hexadecimal. Parse_string, radix, converts a string to an integer based on the specified base. Parse_float_string converts a string to a floating point number. Is nan value checks if a value is nan, not a number. Is finite value checks if a value is a finite number. Date functions. Date.now returns the current timestamp in milliseconds. Date.parse date string parses a date string and returns the corresponding timestamp. New date creates a new date object representing the current date and time. Get date returns the day of the month for a given date. Get month returns the month, 0 to 11, for a given date. Get full year returns the year, 4 digits, for a given date. Get day returns the day of the week, 0 to 6, for a given date. Get hours returns the hour, 0 to 23, for a given date. Get minutes returns the minutes, 0 to 59, for a given date. Get seconds returns the seconds, 0 to 59, for a given date. Set date day sets the day of the month for a given date. Set month sets the month for a given date. Set full year sets the year for a given date. Set hour sets the hour for a given date. Set minutes sets the minutes for a given date. Set seconds sets the seconds for a given date. Math functions. Math.absx returns the absolute value of x. Math.ceilx rounds x upwards to the nearest integer. Math.floorx rounds x downwards to the nearest integer. Math.roundx rounds x to the nearest integer. Math.max values returns the largest of the 0 or more numbers. Math.min values returns the smallest of the 0 or more numbers. Math.random returns a random floating point number between 0, inclusive, and 1, exclusive. Math.palbase exponent returns the base raised to the exponent power. Math.sqrtx returns the square root of x. Math.sinx returns the sine of an angle x, in radians. Math.cosinex returns the cosine of an angle x, in radians. Math.logx returns the natural logarithm of x. JSON functions. JSON.stringify value converts a JavaScript value to a JSON string. JSON.parseText parses a JSON string and returns a JavaScript object. This concludes the list of core JavaScript functions grouped by category. By understanding these functions and when to use them, you can write cleaner, more efficient JavaScript code for your web applications. Introduction. In this section, we'll dive into several important concepts in JavaScript, including the differences between arrow functions and regular functions, the visibility of methods in classes, public, private, and protected methods, static methods, the garbage collector, memory leaks, and the evolution of JavaScript versions. These concepts are fundamental to understanding how JavaScript works and how developers can leverage the language to build efficient, secure, and maintainable applications. Arrow functions versus regular functions. One of the key differences between arrow functions and regular functions lies in how they handle the this keyword. Arrow functions, introduced in ES6, do not have their own this context. Instead, they inherit this from the surrounding lexical context where the function is defined. This makes arrow functions particularly useful in scenarios such as event handlers or callback functions where you want to preserve the context of this. In contrast, regular functions have their own this context, which is determined by how the function is called. For example, when a regular function is called as a method of an object, this will refer to the object. This difference in behavior can lead to unexpected results in certain situations when using regular functions in contexts where this is important. Another distinction is that arrow functions cannot be used as constructors, meaning they cannot be called with the new keyword to create instances of objects. Regular functions, however, can be used as constructors. Public, private, and protected methods of classes. In JavaScript, classes allow you to define objects with properties and methods. With ES6, JavaScript introduced the concept of public methods, which are accessible from anywhere an instance of the class is available. A private method, however, is meant to be accessible only within the class itself and cannot be called directly from outside the class. ES 2022 introduced private methods using the hash syntax, providing a way to define methods that are not exposed to the outside world. A protected method does not exist natively in JavaScript but can be emulated by convention. Protected methods are typically only accessible within the class and its subclasses. JavaScript doesn't have built-in support for this, but developers often use naming conventions like prefixing a method with an underscore to indicate that it is intended for internal use only. The ability to hide methods, private or protected, adds a layer of encapsulation to your classes, which helps in maintaining cleaner and more maintainable code. Public methods are used for interactions with objects, while private methods allow for more controlled behavior within the class. Static methods. Static methods are functions that are defined on the class itself rather than on instances of the class. These methods are accessed using the class name, not the object instances. Static methods are commonly used for utility functions, factory methods, or any behavior that doesn't require an instance of the class. They cannot access instance properties or methods, but they can access other static members of the class. For example, in a user class, a static method might be used to create a user from an object or to validate input data, which doesn't require an instance to perform the logic. Garbage collector and memory leaks. JavaScript uses automatic memory management, which includes a garbage collector responsible for reclaiming memory that is no longer in use. The garbage collector in JavaScript works by identifying objects that are no longer reachable from the root, such as global objects or currently executing code. Once identified, these unreachable objects are eligible for garbage collection, freeing up memory for future use. However, memory leaks can still occur in JavaScript when objects are no longer needed but are still being referenced. This can happen when there are circular references between objects, event listeners are not removed, or when closures inadvertently hold on to variables longer than necessary. Memory leaks lead to performance degradation and can cause applications to run out of memory if not properly managed. To prevent memory leaks, It's important to carefully manage references and ensure that objects are properly dereferenced when they are no longer needed. Tools like browser developer tools and third-party libraries can help detect and fix memory leaks by allowing you to inspect memory usage and references. Difference between various versions of JavaScript. JavaScript has evolved significantly over the years, with various versions bringing new features and improvements. The evolution started with ES3, ECMAScript 3, which was the version widely used before 2009. It provided the basic foundation for JavaScript but lacked many modern features. In ES5, ECMAScript 5, features like strict mode, getter/setter methods, and array.prototype methods were introduced. This version brought significant improvements to the language's consistency and functionality. ES6, ECMAScript 2015, also known as ES6, was a major update that introduced several new features, including let and const for block-scoped variables, arrow functions, template literals, classes, modules, promises, and much more. This version dramatically changed how JavaScript code was written and structured. After ES6, the JavaScript language has adopted an annual release cycle. ES7, ECMAScript 2016, introduced features like array.prototype.includes and the exponentiation operator. ES8, ECMAScript 2017, added async/await, object.entries, and other enhancements. ES9, ECMAScript 2018, focused on features like asynchronous iteration, rest/spread properties for objects, and the promise.prototype.finally method. ES10, ECMAScript 2019, introduced features like array.prototype.flat and object.fromEntries. The latest versions, such as ES11, ECMAScript 2020, and ES12, ECMAScript 2021, continue to add new capabilities, including logical assignment operators, nullish coalescing, big int, and other performance and developer experience improvements. Each version of JavaScript builds upon the previous one, adding new features while maintaining backward compatibility. As a developer, it's essential to stay updated with the latest language features, as they can improve performance, simplify code, and provide more robust tools for modern web development. Events and event bubbling in JavaScript. In JavaScript, events are actions or occurrences that happen in the system you're working with, such as a user clicking a button, submitting a form, or a page loading. Events allow you to interact with the page or application by responding to these actions. JavaScript provides a powerful event handling system to manage and respond to such events, making web pages dynamic and interactive. When an event occurs, the browser typically goes through a process called event propagation, which consists of capturing, targeting, and bubbling. Yes, that's correct. Capturing happens before bubbling in the event propagation process. Event propagation phases. Capturing phase, also known as trickling down, the event starts from the root of the document and propagates down through the DOM tree to the target element. The event is captured by each ancestor element before it reaches the target element. Target phase. Once the event reaches the target element, the element that was actually interacted with, it is handled by any event listeners attached directly to that element. Bubbling phase. After the event reaches the target, it bubbles up through the DOM tree back to the root. This means that the event will trigger any event listeners attached to the parent elements, starting from the immediate parent and moving up to the root. Summary of the flow. Capturing. The event is captured from the root of the DOM to the target element, from the outermost ancestor to the target. Targeting. The event is handled at the target element. Bubbling. After the target element, the event then bubbles up from the target back to the root. If you use addEventListener with true as the third argument, the event will be caught in the capturing phase before it reaches the target. If you use false or omit the third argument, the event will be handled in the bubbling phase, after it reaches the target. This allows you to control the order in which events are handled, giving you flexibility to choose whether to act on events before or after they reach the target element. Event bubbling is a mechanism where the event starts from the innermost element, the target element, and then propagates outward to the outer elements, parent elements. The event bubbles up through the DOM, document object model, hierarchy. For example, if you click on a button inside a div, the event first triggers the button's event listener, then the parent div's listener, and so on, all the way up to the root of the DOM tree. This behavior can be helpful, for instance, when you want to attach a single event listener to a parent element and have it handle events for all its child elements. This is called event delegation. For example, you might want to listen for clicks on all buttons inside a container without adding separate event listeners to each button. To stop the event from propagating further up the DOM, you can call the stop propagation method within the event handler. To add a click event to all buttons within a container using event bubbling, You can attach the event listener to the parent container and use the event's target property to check if the clicked element is a button. This approach is called event delegation. To set an event listener to capture the event during the capturing phase, rather than the bubbling phase, in JavaScript, you need to pass a third argument, true, to the add-event-listener method. By default, event listeners listen during the bubbling phase, but you can change this by specifying that you want to capture the event instead. Iterators and generators. Iterators and generators are important concepts in JavaScript, especially when dealing with collections of data, such as arrays, objects, or other iterable structures. Iterators are objects that provide a way to access elements in a collection one at a time, allowing the collection to be traversed without exposing the underlying structure. An iterator object must have a next method, which returns an object with two properties. Value, the current value in the iteration. Done, a boolean indicating whether the iteration is complete. JavaScript arrays, for example, have a built-in iterator that allows you to loop through array elements with the for/of loop. Here's an example of an iterator. Const r equals 1, 2, 3. Const iterator equals r symbol.iterator. Console.log iterator.next, //value, 1, done. False console.log iterator.next, //value, 2, done. False console.log iterator.next, //value, 3, done. False console.log iterator.next, //value, undefined, done. True generators are a special type of function in JavaScript that produce iterators. A generator function is defined with an asterisk, function, and it can pause its execution at any point using the yield keyword. The generator function returns an iterator, allowing you to iterate through values produced by yield. Generators provide a convenient way to work with sequences of values over time, especially when you need to pause and resume execution. Here's an example of a generator function. Function number generator. Yield 1. Yield 2. Yield 3. Const generator equals number generator. Console.log generator.next, //value. 1, done. False console.log generator.next, //value. 2, done. False. In the example above, the number generator function is a generator that yields values 1, 2, and 3, and the next method is used to retrieve those values one by one. The advantage of using generators is that they are more memory efficient than creating large arrays or collections, especially when working with large datasets or infinite sequences, as they allow for lazy evaluation. This means that values are produced only when needed, rather than all at once. Conclusion. In JavaScript, events and event bubbling allow developers to handle user interactions efficiently. Event bubbling is a powerful concept for managing events in the DOM, and event delegation helps in optimizing the event handling process. Iterators and generators offer useful ways to work with sequences of data. Iterators provide a standard way to traverse collections, while generators make it possible to pause and resume function execution, enabling efficient handling of large datasets or infinite sequences. Understanding these concepts and how to use them effectively can help you write cleaner, more efficient JavaScript code.